Okay, so let's talk about prime numbers. They have two factors. Okay, you'll usually see teachers say, oh, they have two factors themselves and one. Now, actually, if you just think about it in terms of they have two factors and two factors only, rather than anything else, it just makes it a whole lot easier. Now, the first prime is actually 2. And the amazing thing about that is it is the only even prime number. Because anything more than 2 would be in the 2 times table. Now, why isn't 1 a prime number? Well, that's because 1 has only one factor, so it cannot be prime. So, for instance, 1 times 1 equals 1, so it only has one factor. Whereas 2 is prime because 2 is made up of 1 times 2, so it has 2 different factors. Three is prime because 3 is made up of only 2 factors. Whereas 4 isn't prime. Where's my red pen gone? I've lost it. There it is. And we call that non-prime, rather than not prime. Okay? Because you have 1 times 2 and, 1 times 4 and 2 times 2. So it has 3 factors. Now, if an item has an odd number of factors, that's a really special kind of number, and that's called a square number, because essentially one of the factors is multiplied by itself to give you a square. We could draw a square with the side lengths of 2 and 2, and because you'd have 2 going this way and 2 going this way, we'd end up with 1, 2, 3, 4, and 4 would be an area of a square. So 4 is non-prime, but it's also a square number because it would give you the area of a square with a side length of 2. So let's try 5. 5 is going to be prime because 1 times 5 equals 5. You can't make it any other way, and it has 2 factors. So it is definitely prime. 6, well, let's try it. We can have 1 times 6 or 2 times 3. Notice that apart from square numbers, all of our factors come in pairs. Square numbers are the only ones that have an odd number of factors because the same number is times itself. So you end up with an odd number because this one creates its own pair, so it's only counted once. Primes only have 2 factors because there's only one pair of numbers that can create it. 6 has 4 factors, so it's non-prime. So let's just give ourselves a quick rundown of the prime numbers. Remember, the first prime number is always 2. 1 is not a prime because it only has one factor, whereas 2 has 2 factors. And remember that 2 is the only even prime number, and they'll use that lots in the thinking problems at the end of the exam to try and catch you out. Then there's 3, then there's 5, then there's 7, then, hang on, So far it looks like all of the odd numbers, but what about 9? Well, 9, if you're unsure, check it, is 1 times 9 or 3 times 3. Oh, how many factors has it got? 1, 2, and 3 is repeated, so it's got 3 factors. So what do I know about an odd number of factors? Oh, it's a square number. So 9 is a square number, so it can't be a prime. 10 is in the 2 times table. 11 can only be made by 1 times 11, so that would be our next prime. 12 is even, so that won't work. 13 can only be made by 1 times 13, so that's right. 14 is even. 15, let's try 15. That would be 1 times 15 or 3 times 5, so it has 4 factors, so it can't be a special case, it can't be a square number, and it can't be prime. 16, again, it's even. From now on I'm not going to mention the even numbers anymore. 2 is the only even prime, so let's not bother about them anymore, because everything else will be in the 2 times table, so it will have more than two factors of 1 in itself. 17 is good. 19 works. 21, well, 21 can also be made by 7 times 3, so it's not just 1 and 21, so that's no good. 23, can't make it any other way. 25, well, that is 5 times 5, so I know straight away that that is, again, a square number, because it would have an odd number of factors. So 1 times 25 and 5 times 5, it would have 3 factors. Not all square numbers have just 3 factors. It's just at the moment we're looking at very small square numbers, so they have fewer factors than the others. 27, can we make 27? Well, one of the really good checks for prime numbers is if 3 will go into it. So any number that can be divided by 3 or 9 will add together to make 9. So for instance, 27, if we do 2 plus 7, that makes 9. Any numbers that their digits add up to 9 will be in the 9 and hence the 3 times table, so that's not right. 29 is though. 30, obviously not, because it's even. Whoops, sorry about that. 31. The other one to check out is 33. But 33, if the digits are identical, then 11 will go into it. 11 times 3 would give us 33, so that's not right. 35, if it ends in 5 or 0, that's going to be in the 5 times table, because remember the 5 times table goes 5, 10, 15, 20, 25, 30. Notice that the end units of each number goes 5, then 0, then 5, then 0, then 5, then 0. So 35 won't work. 37 will. Okay, I'm going to show you a really helpful trick right now. If you have a Casio Plus, an FX83 or an FX85, they have this amazing button called a factorize button. Now basically, if you type in the button that you want to check whether it's a prime or not, if you turn it on, she says, that's the on button, type in the button, type in the number you want, sorry, you must press equals to get it to show in this corner, then press shift, and I don't know if you can see, but there's a button, these signify minutes and seconds, etc. But above it says fact for factorize. If you press shift and then factorize, if it's prime, it will literally just stay in the corner as it is. So I know that that's definitely prime. But if I give you a non-prime, so for instance 33, and I press equals, then shift, then factorize, it tells me what other factors it can be broken down into. And those factors are always, it's actually a prime factor decomposition, which means decomp means to break down. So for instance, when you decompose something, you break it down into its original chemicals. And it's prime factor decomposition because the factors it breaks it down into are always prime. So 3 is a prime and 11 is a prime. So because it's made up of other prime numbers, 33 cannot be prime. So let's try 39. So 39 equals, shift, factorise, and 39 is 3 lots of 13s, so 39 is not a prime number. Okay, 41, let's try it. 41 equals, shift, factorise, and look, it stays the same in the corner, so 41 is a prime. Now, we can carry on like this, and eventually we're going to end up getting all the way to 100. Now 100 isn't a prime, and 99 isn't a prime because 11 will go into it 9 times. But I'm now going to pause and fill in all the numbers that I'm missing. So here is a quick list of all of the prime numbers that you essentially need to know off by heart or be able to work out accurately, because it actually asks that you know them from 2 till 9 to 97 in the maths syllabus, and you can be tested on them. So please, please, please get used to using your factorise button on your Casio and try and learn as many of these off by hand. I don't know them all yet, I have to say. I kind of get to 53 and I need to work out the rest.